All right, so continuing in this idea of dealing with triangles, combining kind of two lessons here, what makes a triangle congruent, and then looking specifically at angle, side angle congruency. So quick little review from what we talked about previously this week. CPCTC, or corresponding parts of congruent triangles, are congruent in this case. We talked about more than just triangles, but now we're moving specifically to triangles. So two triangles are congruent if and only if the corresponding pairs of sides and corresponding pairs of angles are congruent. Should be pairs, not pairs. To decide whether two triangles are congruent, you compare the corresponding parts, and then what we eventually get to is we don't have to compare every single one, all 6 of them. We can compare some of them. All right, so let's look at a couple examples here. So determine whether given triangles are congruent. Explain if the triangles are congruent. Write the appropriate triangle congruence statement. So number 1. So we look at this. We're going to compare the sides. So we have to go corresponding sides. They don't tell us, but we do know smallest goes with smallest. So that's the same. And then we go middle to middle, so that one's not the same. And then those are the same. Well, right here, we have corresponding parts that are not congruent or equal, so therefore this one is. And so we can go with no, since CB does not equal FE. All right. Okay, let's look at number 2 now. So angle-wise, we have 30, 30, 60, 60, 90, 90. So all the angles are the same. But let's look at sides as well. So we have smallest side, 1 meter and 1 meter. So we're good. 1.7, 1.7, 2, and 2. So we would say yes on this one. And our reasoning would be all the sides are congruent or equal in measure, and all angles are equal in measure. And then our congruency statement is going to be, I'm going to start with my right angle. So let's go triangle H, and then I'm going to go up the 1.7 to G, and then down to J. And we'd state that is congruent. We have to start in the same spot, so it's triangle L. And then we're going to go up, technically down, but through the 1.7 side to K. And then down the hypotenuse, the 2 to M. So notice that those are all written in the same corresponding order. All right, so your turn. Determine what those are. You guys will answer that as well. All right, so now looking, if we have congruent triangles, or we want congruent triangles, what would the variable then be in order to force that? So as we match some things up here, we have 30 that has to fit with 30, 50 that fits with 50. So then if these were to be congruent triangles, 2y plus 20 would have to fit with 36. So we can say 2y plus 20 equals 36. Subtract the 20. 2y equals 16, divided by 2, and y equals 8. All right, so number 6 here, your turn. Working on that. Now you're going to deal with angles. So remember, little hint, triangle sum theorem will be a good thing to remember here. All right, little reflection question for you. So looking at the measure of two angles of QRS, are 18 and 84, and the measures of two angles of triangle TUV are 18 and 76. Is it possible for the triangles to be congruent? And then explain. Okay, so come up with that answer and be ready to share in class. All right, so let's look at number 8. Determine whether triangles are congruent. Explain your reasoning. Also, if congruent, write a congruency statement. So as we look at this here, we have a couple of things that we know. We see we have 1 inch and 1 inch. I have 38 and 38. And then we have these missing angles here. Angle R for this triangle and angle S for that triangle. But we do know we can find the third angle because we know total angles in a triangle add up to 180. So if we do 38 plus 72 and subtract that from 180, so when we do that, that gives us 70 degrees for R. And so then we don't need to find S because 70 does not match with 67. Now, the reason I can say this is it's this new congruency that we can check. We don't need to know all the parts. We don't need to know all the sides. We have this one that's called angle, side, angle congruency. So as I looked here, we have an angle Q, right, our 38. So there's our angle. We have a side and the 1 inch QR to TU. So then I was really hoping that R would be congruent to U, and then we could have angle, side, angle, but that is not the case. So then this is not congruent. All right, so your turn to work through 9 and 10. And remember, off of these, what we're looking for is we want to use angle, side angle as a hint. So if I can show that my angle, side, and angle, remember that side has to be between the two angles. If those are congruent, then the triangle is congruent to the other triangle. So look at that for 9 and 10. Again, write the congruency statement if they are congruent. All right, little reflection here on 11 in the diagram below. Question is, do you need to find measure of angle K to show that triangle JKL is congruent to triangle MNP? Do we need to know that measure there? And then why or why not? And last problem, a little proof, bringing back those ideas there. So work through the reasonings on that. Little hint, so midpoint, remember what a midpoint does? That's in the middle. And so then what that gives you is equal sides. And so a phrase or reason you might use in here that we haven't used before is definition of midpoint. So just a little hint on that one as well.